Okay, boys and girls, we are going to work with distributive property again today. Distributive property, what is it? Well, that's when you have an unknown fact and you want to simplify it by breaking it apart. And we know that we can break apart an unknown fact and put it back together in order to get the product of the original problem. So we're looking at this array here. This array represents this multiplication equation here. Remember, an array is just a rectangular shape made of equal rows and columns. This shows us multiplication. This is how we model multiplication. So let's pay close attention to the jobs of each of these factors. Remember, factors are just numbers, the two numbers that you're multiplying. In this case, our factors are 4 and 7. 4 represents the number of rows. Notice 4 here and notice 4 rows here. 1, 2, 3, 4. Notice the number 7 here. The job of this factor is to tell us how many is in each group, okay? The first factor tells us how many groups we have or how many rows. The second factor tells us how many is in each group. In this case, columns can help us determine that since they are all equal. 1, 2, 3, 4, 5, 6, 7. So we have 7. 7 columns. That's why that 7 is here. This 7 here is represented by the 7 columns. So let's say to ourselves, this is an unknown fact. And we want to use distributive property to break it down into simpler facts so we can solve it. So you want to think of distributive property as a strategy. It's a strategy we stick into our math toolbox to pull out whenever we get stuck. So looking at this, when you see this array and you see the rows, you're actually seeing the number 4 here. And when you look at this array and you see 7 columns, you're actually seeing this number 7 here. Now remember, arrays are just training wheels to being able to solve. Our goal is to be able to solve multiplication equations using this strategy without arrays eventually. But we're going to use them to our advantage until we don't need them anymore, just like training wheels. So I want you to realize that when we talk about splitting rows, we're actually talking about splitting the 4 here, decomposing the 4. And when we talk about splitting the columns, we are actually literally talking about splitting the 7. Now, according to distributive property, we are only allowed to split one of the factors. You can't split both of them. You're only allowed to split one of them. So this is where you have to make a decision. Well, how do I want to split this array in a way that it's going to make it simpler for me? It's going to make it easy. So you want to look at your factors. Do I want to split 4 or do I want to split up 7? Either way would work. Now, a misconception is that you have to split it in a way where there's equal groups on both sides. That is not true. You can split up a factor in any way that is comfortable for you. So we're going to look at this problem in 2 different ways. We're going to first solve this problem splitting it by the columns, and then, or the 7 here, and then I will show you how to split it by the rows, and to just show you that when you split your array, it doesn't have to be equal, okay? So I said we are going to split the columns. So we're going to figure out how to split this in a way that's going to simplify it. So when I look at the columns and I'm thinking about splitting the columns, I'm literally thinking about splitting this 7. Now we know that 7 is not an even number, so it's not going to be able to be split equally anyway. So this is a great example. But I am going to take 7 and I'm going to cut it. I'm going to cut it in a way to simplify my problem here. My ultimate goal is to get 4 times 7. So all the work I do after this is going to be is for the product of 4 times 7. So I'm looking at my 7, and I'm looking at my rows here. I'm going to go ahead, and I know my two's facts very well, so I'm going to say 1, 2, and split. And that leaves me with 5 columns here and 2 columns here. Notice that if I add 2 and 5, I get 7. So pretty much all you did was you had 7, and you decomposed 7 into 2, and you decomposed 7 into 5. That's all you did. And now we are going to make simpler equations with these 2 new factors. And remember, the 7 represented our columns, so these factors are going to be our second factor in our new multiplication equation. So we made 2 new multiplication equations. And that is modeled for you up here in the array. So here's the first one. And here is the second one. Let's look at this first one. This first one shows 4 rows. Notice how the 4 is going to be consistent. There's going to be we did not change, we did not touch that factor. We didn't decompose that factor. We decomposed the 7, not the 4, so the 4 stays the same. So we have 4 rows of 2. There are 2 columns now. Now, these parentheses just symbolize this array up here. I'm going to put a plus sign here because remember with distributive property, we break it apart so we can put it back together again. That's what this addition symbol stands for here. This is to remind us, oh, we're going to have to put this back together so we can get the total amount and get 4 times 7. That's our ultimate goal. All right, it's time to find out what our other simple fact is. So notice that we have the 5 over here when we decompose the 7. And notice the 5 columns here. Also notice that the rows did not change. There's still 4 rows of, and now we put 5, which is the same as saying 4 times 5. This fact represents this smaller array. This fact represents this smaller array. Also notice that I broke apart the 7. I broke apart the 7. So if you think about this without the array, I just took that 7 and I split it into 2 and 5. If I add it back together, if I add 2 and 5 back together, I would get 7. That's why that works. So now my job is to solve for these smaller equations so I can add those 2 products together to get the original the answer to my original problem. So 4 times 2 is 8 plus 4 times 5 is 20. According to distributive property, I can add these 2 numbers together, and that's going to give me the product of 4 times 7. 8 plus 20 is 28. So 4 times 7 equals 28. How can you check your answer? Well, you can look at the array as a whole number again and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Notice that even though we split this apart, the total amount did not change at all. So I want to show you that same problem. I'm going to show you that same problem, but this time we are going to split the rows. So we still have 4 times 7 here. So last time we split the 7. This time we're going to split 4. So if I decompose 4, how can I split that in a way that would simplify my multiplication equation? Well, in half, of course. If I split my rows in half, I know my 2 facts. So by doing that, I'm pretty much just taking that 4, cutting it in half, and getting 2 and 2. 2 plus 2 is 4. All right, it's time to make my new, simpler arrays here with my parentheses. I'm going to do the top one first. 2 rows of 7. Notice how my 2 represents my rows. This 7 still represents those columns. That did not change. Remember, distributive property only allows me to decompose one factor. I'm going to put that plus sign because I have to add it back together to get my final product. All right, now since 4 is an even number, that pretty much leaves me with my bottom array being also 2 times 7. Now I know if I add the 2 products here together, I'm going to get my total sum, my total amount. So 2 times 7 is 14, and 2 times 7 here is 14. I'm going to bring that plus sign down to represent my addition here. 14 plus 14 is 28. Notice how we received the same product and just solved it a different way. We're going to try this in our math books now. So go ahead and get your Envision math book out and turn to page 100. Turn to page 113 in your Envision math book. Okay, we are on page 113. Here, we're going to take another look at distributive property. I put in Schoology counters. It's like virtual counters for the bottom half of this assignment. So you might need those counters when doing this page, and feel free to use them. That's why I put them there. Another look. The array below shows 6 times 4, or 6 rows of 4 circles. You see that? 6 rows of 4 circles. You can draw a line to break the rows, the 6 rows of 4 circles into 2. And pretty much you are taking that 6 and you're splitting it into 2 and 4. Because if you add 4 and 2 back together, you would get 6. So you're taking those 6 rows and you're splitting it to simplify the problem because you are treating this like an unknown fact. We know that distributive property tells us that you can break apart a multiplication fact, and you can add these 2 products together and get the total amount. So we started with 6 times 4. We can break that into 2 times 4 and 4 times 4 and put it back together again, and we will get the answer to 6 times 4. This is a strategy. Remember that. So for number 1, we are going to draw a line to separate this array here, and also for number 2, we're going to do the same thing. And we are separating each array into 2 smaller arrays, and then we're going to write our new fact. So looking at number 1, how would you split it? You could decide to split the 4. Remember that 4 represents the 4 rows. Or you could split the other factor, which is 3, which is represented by the columns. Which would be easier for you? All right, I know how I would split it. I would decide to split this factor by the 3. I would split this 3, and I would decompose this 3 into a 1 and a 2. I'm basically thinking of what 2 numbers make 3. And what 2 numbers would make easy multiplication facts? Well, 1 and 2 are super easy. You can't get any easier than that. So The only factor that I split up here was the 3, and I can model that by taking a line and going straight down here. Here, I split 3. If you look at this as columns, 3 columns, I split 1, and here's 2 on this side, making 2 separate arrays. I'm eventually going to put these back together to find the total amount. But right now, this problem is just asking me to fill in the missing factors. So I can look at this and automatically know, because I know how my multiplication problem should be set up. I know that first factor represents my rows. And I know I did not touch my rows. I did not split my rows. That 4 is 4 to stay. This 4 is going to be the first factor for this array. Remember, these parentheses just separate these arrays up here. See how I boxed this up? It's the same down here. The parentheses box up the multiplication problem. So I have 4 rows still. And then in this one, you can see I still have 4 rows. My rows did not change. I only split my 3. What did I split my 3 into? 1 and 2. This array shows 4 rows of 1, which is the same as saying 4 times 1. And this array shows 4 times 2, which is represented right here. Let's move over and do number 2. So I have a 5 as a factor and a 6 as a factor. Which one would you decide to split up and break down and decompose? I know what I would do. What I would do for this one is I would, since I have 6 and I know my 5s really well, I would decide to split this by columns again. So what 2 numbers that I can multiply easily would make up 6? 1s and 5s, of course. 1 and 5 makes sense. I can model this by drawing a line after 1 column. So now here I have an array with 5 rows, 1 column, and here I have an array with 5 rows of 5. Notice how my first factor, my rows did not change. I have 5 rows here. 1, 2, 3, 4, 5. What did change is I now have 1 column. I only split my columns up. Here, notice how I still have 5 rows. That's my first factor. Always, always, always. And notice the only thing that changed was my columns. I have 5 columns now. Now, this is the part of the book where I suggest you using those electronic chips that I placed into Schoology to help you out. So I'm going to go ahead and use the chips up here since I have stamps. And if you need, please use those chips I put on Schoology. It says manipulatives. Use them. It's the same chips I showed you in my previous screen. So I can make 4 rows of 6 here. My original problem here is 4 rows of 6. Let's see, where would this let me make this? I'll make it right up here. So I need 6 in each row, and I need 4 rows total. So I'm going to go ahead and do that. All right, 4 rows represented here and 6 columns represented here as well. Now they already did the hard part. They split the array already. They split the multiplication fact already. As you can see, the 6 here, the columns are the same. The 6 here represents the columns. The 6 here represents the columns. The 6 here represents the columns. So they decided to split the 4 here. What did they split 4 into? What two numbers can you add together to get 4? Well, they already give you a clue here is 1. So they decided to decompose the 4 into a 1 row. So I'm going to show you 1 row. So what would be the missing number? There's 1 row. So that leaves me with how many more rows? If you said 3, you are correct. Notice how this 1 and this 3, when you add them together, you get the number that you split up. And notice how they weren't split up equally. It doesn't have to be equal. Let's try this without an array this time. So here I have 5 times 8. Basically 5 rows of 8, 5 groups of 8. The first thing we want to see and solve for is, okay, what number was broken down? What number was decomposed? So looking at the other, we're going to say these are arrays, but remember, distributive property allows us to break apart a multiplication fact into smaller equations. So I only can split one factor. That means one of them is going to stay the same. 8 is the same here, here, here. They all represent those columns, right? The amount in each group. So the person who made this problem split that 5. How did they split that 5? Well, they give you a clue. Let's look at it over here. Here's 5. If I was to decompose 5 to get two numbers that would equal 5, how could I do that? So here, they gave you your clue. One of those numbers is 2. So what's the other one? What could you add to 2 to get 5? You are absolutely right. 3. 3 is the missing factor here. Let's keep going. I'm going to erase this part so we can have more room here. We're going to do this one without the array as well, but remember I have those manipulatives there for you to help because you're going to have to do a few of these on your own for independent practice. So 4 times 5 is my original problem. I'm going to use distributive property to solve it, so I have to break it down into smaller multiplication facts. Okay, now this one's a little tricky because I don't really notice the pattern at first. I do, however, know that one of these numbers are going to stay the same. And looking at my first multiplication problem right here, I notice a 5 and then a 5 here. That tells me that this one is also going to have 5 columns because the number that was decomposed and split apart was the 4. And looking at 4, how can I split that in a way? Here they have 2. So this is pretty simple. They split this with 2 being one of the numbers. So what can I add to 2 to get 4? 2. Notice how 2 and 2 equal 4. Also notice how 5 did not change because only one factor was decomposed. Only one factor was. That's what distributive property says. It says you only can break apart one of those factors to make smaller ones. So let's take a look here at 7 times 6. So, looking here, you are missing your columns, your second factor in both of them, and you're missing the first factor in the second problem. So thinking about these as arrays, your column, you started with 6 columns, and you have to figure out what the missing ones are in your new arrays. You know that it's going to stay the same because look, there's a 3 here. So you know that this 7 was split. The 7 was decomposed because that 3 is sitting right there as the first factor. That 3 is sitting right there as the first factor. Exactly the same spot that the 7 is sitting. That tells us that 6 is not going to change, or 3 is. So what can you add to 3 to get 7? You're right, 4. 4. Now, I want you to use your chips, your manipulative chips. I wanted to just model for you how I would solve this without the training wheels, but I want you to use the manipulative chips until we get extremely comfortable with this. But I want you to do 7, 8, 9, and 10 independently. And then you have an exit ticket to finish right below this video.